Thanks for joining. So this session is about Kubernetes development, kind of, but for Java developers. So we're going to try to take an application from more or less zero to more or less production ready, because we can only do so much in 45 minutes or less. But so I'll make a little bit of a shortcut here and there, but hopefully it'll all make sense. And if not, I'm happy to answer questions afterwards. So before we get started, I'll maybe introduce myself real quick. So I'm Kevin Dubois. I'm a developer advocate at Red Hat, and I'm based in Belgium. And fun fact, I'm moving in this summer to just an hour from here to Samoin, so I'll be a little bit closer, yeah. Anyway, so Kubernetes for Java, right? So some of you might have heard of this term, Kube Native Java. And what does that really mean, right? Because, I mean, at the end of the day, they say, like, you can deploy anything to Kubernetes. And while that's kind of true, classic Java applications, deploying them to Kubernetes is not so easy, or so, you might run into some issues. But let's look at what Kube Native Java is. So if you look at, our, let's say, traditional Java applications that especially if you've been in the business for a while, they weren't built for deploying to cloud-native environments, right? They weren't deployed for, multiple instances in a kind of distributed architecture. There was more or less like a monolith deployed in a very kind of, or at least in the enterprise world, in a very beefy kind of VM or something, and it could just take all the memory that it needed. Because, the throughput was at the expense of footprint, right? So you can have pretty big servers as long as your throughput is good, and Java was optimized for that, right? The idea was that you had these long-running processes, and you have dynamic loading, so you don't necessarily need to redeploy very often. And so because of that, you have this kind of rich dynamic behavior for mutable systems, so that you don't have to redeploy, because that's always a pain, right? I mean, in my experience too, as a Java developer in the past, we did releases maybe like every other month or something, and it was always a very painful process. Kubernetes native Java, on the other hand, means that your Java application needs to be able to take advantage of throughput by scaling the application, by creating more instances when you need it, and then less instances when you don't need it. That's kind of the nice thing about Kubernetes, right? You don't, or more or less, you don't use as many resources when you don't need them, and when you do need them, you can scale up very quickly and easily across different servers, across different nodes, even across different regions. And but the thing is, you deploy those applications in containers, and containers should be immutable. Immutable meaning that if you make a change to your container, inside your container, that is not going to persist by default, right? So you need to kind of keep that in mind. So all that kind of dynamic behavior that we had in our traditional Java applications, which worked really well for traditional deployments, is actually a detractor for running in the cloud, right? Because if you do a lot of kind of optimization on the fly when your application starts up, and you dynamically load all these different things, that needs to happen every time a container starts up, right? So if you have 2 instances running, you get more load, so you start up a couple more instances. Every time that same work needs to happen, that's not so ideal, right? So the idea with Kube Native Java, with Java kind of optimized for the cloud, is that we kind of remove that dynamic behavior as much as we can, and we move it to the build phase. So we'll see some stacks that do that pretty well. And footprint is important in the cloud because you pay for it, right? If you deploy to one of the cloud providers, you'll notice that the more memory you're using, the more you're paying. It's a very kind of linear equation. And startup speed is going to matter too, right? Because if you want to scale fast, your application needs to start up fast. If it takes 10 minutes, requests that are coming in that need to wait for 10 minutes, it's not going to work, right? So you need applications that start up faster. So if we look at the JVM, with regards to startup time, you can see here is kind of a semi-scientific graph. You can see the bottom line is the amount of requests per second that are coming in, the blue line. And you can see at some point we get more requests coming in, which is presumably good for us, right? More users are using our application. But you can see as the requests go up, your Kubernetes environment will notice there's an increase in memory and CPU, so we're going to create more instances, and that's great. But the JVM that is running in those containers, it takes a little bit of time to really get up to its maximum requests per second, its maximum capacity, right? So here you can see, even though we scale up more instances, it takes a while before we can actually have the maximum capacity. And at that point, in this example at least, we see that we lose requests, right? So that's not so ideal. We need something that starts up faster. So in the Java world, there's been a lot of improvements, the JVM itself, and also projects around it that make that startup time a lot faster, right? So that we don't need to go to different stacks. We can use our knowledge of Java and all the really cool stuff that's in the Java ecosystem. Right, because at the end of the day, if you can't scale fast enough, you lose requests, you lose users, you lose potentially money. That's not so great, right? So some projects that are working on that, you have GraalVM, so you can actually compile your Java application to native binary, have much faster startup time, a smaller footprint. You have projects like Crack and Helidon and Micronaut. We also have Project Leiden to improve all these things. So there's a lot of initiatives in the Java world. But when obviously I'm a little bit biased, but one stack that does Kubernetes native Java development really good is Quarkus, and so that's what I'll focus on today. But I'll also kind of put some links to Spring. I guess I missed Spring here, but the Spring ecosystem is also working, of course, on optimizing the startup time and everything. So you may have already seen this slide if you've seen any kind of Quarkus talk. It's kind of showing the difference between a traditional cloud native stack and Quarkus with native compilation. You can see the difference in memory usage, right? Which is very important in the cloud native world. And you can also see in terms of startup time, you get a vast difference between using a traditional Java application versus using an optimized Java stack. So when we want to move to the cloud, we need to definitely take that into consideration in terms of startup time, memory usage, and resource usage in general. So the title of the talk today is from zero to production. So of course I have to start somewhere, and this might be kind of the endpoint. If we have time at the end, we can actually play this game. So basically I'm going to build this little car racing game. And every time, so you can participate by tapping or shaking on your phone. I haven't decided which version we'll play. But every time you tap or you shake, a request is going to be sent via REST. It's going to go into a Kafka topic, and then perhaps we'll also have a little bit of persistence in a database. This is kind of a very relatively small application, but a little more representative than just your hello world, right? So I'll try to work towards this application. So the architecture here is, so like I said, you have your REST calls that go into the application. It sends those power events to a Kafka topic. And so let's start with the first part, right? Let's do our MVP, if you will, of sending some requests and then picking those up or sending them to a Kafka topic. So I'll go to my IDE here, and I hope, is that big enough in the end in the back? Good? Okay. If not, let me know. So we have here a little bit of a start, right? So we have a power resource, which is basically a REST endpoint /power. And then I have this post here So this is using Quarkus, and you can see basically it's very simple. So when I post something to this endpoint, then I'm going to emit it to a channel, and that channel happens to be, in this case, a Kafka topic. So you can see here this emitter. So this is part of the microprofile specification, if you're familiar with that. I'll come back to microprofile a couple times in this talk as well. So basically, I define a channel where it needs to send my requests, and then in my application properties, I have it configured to actually send those requests to this Kafka Power topic using small-write Kafka, which is, again, an implementation of microprofile. And so by doing that, we can send some requests. So let me try that out real quick. This is not necessarily like the core part of this talk, but it just gives you an idea of what we're trying to work with, and then we'll try to optimize or create some resources to get that to production, in quotes, of course, on Kubernetes. So I'm running this application on my local machine in dev mode, and so I just want to test it out real quick. So I'm going to go to my browser right here, and wow, I made a Quarkus application, very cool. And then we have some endpoints, and you can see here's the Power endpoint in post. So I'm going to just test that out just to make sure that it works. So in Quarkus, you have this dev UI, and it's pretty handy to test things out because I added the Open API extension, which allows me to also see the endpoints, and I can also, it gives me this Swagger UI out of the box that I can test with. So here's my Power resource, and I'm just gonna test it out. Where's the try it out button? It's here. Try it out. And then let's say that I'm sending for a given device, so I can give it whatever name I want, my cool car, and then just a number. So this is like every time you tap, how many Power units get sent. So let's try that real quick. Make this a little bit smaller, and we'll execute. And so we should see that there's a response here. Great success. So great. This worked. And now we can also see if it actually made it into my Kafka topic. So if you add the Kafka extension to your Quarkus application, you also get this Kafka client thing here. And then you can see here that we have a topic, Power, and sure enough, we can see that our device, my cool car with Power 2, was inserted into my Kafka topic. So anyway, so this is testing a little bit on my local machine, and everything is working. So now I want to, of course, go and deploy this to Kubernetes. This is the extent of my really hardcore testing on my local machine. But when I want to go to Kubernetes, of course, I have to create some resources, right? So who here has some experience with creating containers? Let's maybe start with that. So we got, most people have done something with containers. How many people use Docker for this? Okay, so most people use Docker. Does anybody use like cloud native build packs or Jib or some other? So it seems like most people use Docker. Anybody who uses Podman? It's kind of the same as Docker, right? Okay. Cool. So or at least some of you know how to create containers. How many people of you are comfortable deploying that container to Kubernetes? So a few less hands. So you can deploy to Kubernetes in a few different ways. There's some projects that try to make that a little bit easier. But at the end of the day, if you have worked with Kubernetes, you'll know that most of the time YAML comes into play, right? You need to learn a little bit of YAML, and you need to know how to create deployment and a service and all those different Kubernetes concepts. Now, for Java developers, that's like, that's another thing we need to learn, right? And so it's kind of inevitable. You do need to maybe get yourself a little bit familiar with Kubernetes YAMLs, but it's actually not so bad. So in this case, What I'm going to use is Quarkus, but if you're maybe a Spring developer, you can also use a couple different ways, like with Spring Cloud. And they recommend, for example, using kubectl create deployment to create your YAMLs. With Quarkus, on the other hand, I'm going to use a different method. So here you can see that this dev mode is still running, right? So look at my target here. I'm going to do a quick Maven clean so that everything that was generated before isn't there anymore. And now I'm going to add oops, I hit a button that apparently killed my previous terminal. All right. So now I'm going to add an extension to my application to work with Kubernetes. So an extension is basically like a dependency. So it's just a dependency that gets added to your pom.xml. So I could do it in the pom.xml, or I can just do Quarkus extension add Kubernetes. So keep an eye out here on our target folder. Once this extension gets added, we should see that a new folder here gets created in just a moment. I may need to refresh my browser window. Oh, no, it actually did it right here. So it added a Kubernetes folder. And in that Kubernetes folder, you can see it added a JSON and a YAML, because you can also use JSON. But most people in the Kubernetes world use YAMLs. And you can see that it actually generated it scaffolded some YAML for me. So you can see here that it created a service, which is basically how how you can talk to a pod, and a pod is basically what contains a container. So it created this service, and then with the selector name Kube Native, and then that selector points to this deployment, which has the name Kube Native. So it created all this for me with replicas 1, which basically means one instance of my application. So if you wanted to have multiple instances, you change this to replicas, whatever, or you can, configure auto scaling, but that's not necessarily our concern. But you can see here some interesting things that it added too, is like the Git repository and everything, and of course our container. So here the image is pretty important, right? So it needs to know where to find the container image that we're deploying. Of course, I haven't created a container image, so I should probably start with that. So you can see here it says quay.io/Kevin Dubois/demo. And that's because in my application properties, I already configured these settings right here. So I have the image registry, the name of my registry, and then the name of my application in my application properties, so that when I create my container, it already picks up those values. So I have a Docker file that was supplied here with my application when I created it. So there's a Docker file JVM, a Docker file native. So based on how you are building your application, if you just create a jar, I would, of course, use the JVM Docker file. There's also Docker file native. So if I want to create a natively compiled application with GraalVM, that's also an option. So I'm just going to do this real quick. So I could use Docker build and then point to the Docker file and specify the folder that I want to build from. Or I can just use Quarkus image build, and it's kind of the same concept. So I'm going to skip the test. So this should build my container image. Let's see if it works. And then in a second, I should see that a container was created. So we can see here that it's going through the Docker file. So by default, it uses this Docker file JVM with this command. Again, if you're a Spring person, you would do something very similar, right? You would do Docker build with a Docker file. So let's see if our container was created. In this case, I'm going to use podman-desktop, but you can use whatever you want, of course. And let's see in the images, and sure enough, there's my image created 27 seconds ago. And so now I can deploy that. So I can do podman push or Docker push to push it to my registry. And then finally, I'd be ready to deploy it to Kubernetes. So if you want to use a registry, you can use Docker Hub, you can use Quay or whatever, and then you can use that to pull the image into your Kubernetes environment. There's some Kubernetes implementations that also allow you to do a build inside that Kubernetes stack, and then have an internal registry. So it kind of depends on your use case. But for the most part, I think the classic step is to just push your image and then use it in your Kubernetes YAML that we just saw, right? So I can do that real quick. So I can do Docker push, but I think I need to log into my registry first. So let's see. I'm just gonna skip that step because I don't remember where exactly I saved my password. But I already pushed it anyway, so we're all good. Now I need to apply finally my Kubernetes YAML to deploy it to a Kubernetes cluster. So maybe you have a Kubernetes cluster available in your organization. If you don't have one and you want to play around with Kubernetes, you have a couple options, right? So you can use a Kubernetes running on your local machine. There's Minikube, there's Kind, which is Kubernetes in Docker, and there's a few other ones. If you want to play around with Podman Desktop, it actually provides you with some extensions that allow you to create these kinds of clusters on your local machine as well. So you can play around with that. I already have a cluster running, so I'm just going to use that one, which is right here. No, anyway. I'll go to developers.redhat.com. Oh, I don't have any network. I thought I started my hotspot. It's turned off. So I tried earlier to apply my YAMLs and found out that the local network, which is really fast, which is great for speakers, but I couldn't SSH with it. So that was kind of a problem if you want to apply your YAMLs, because it creates a connection with your Kubernetes API, I guess through SSH. I'm not entirely sure. But in any case, it wasn't working. So I need to go on my hotspot here, and that should fix it. So if you want to play around with a free cluster, you can also go to developers.redhat.com. There's this developer sandbox, which is what I usually use. Oops. Let's go to it real quick here. That's not what I clicked. So this hotspot is a little bit slow. Come on, go to developers.redhat.com, and then developer sandbox, do this, start it, and then I should be going, I need to log in. And then finally, we have to do exercise some patience. You end up in this cloud console. Man, that's a lot of clicks, huh? And with a little more patience, we should see this environment in the cloud. More clicks. All right, so eventually we will see the UI of this Kubernetes cluster finally, and then in my topology here, we should see that I've already created the database in the Kafka instance for my application. So this is in my Git repository. If you want to recreate this, basically here in this Kube folder, we have a Kafka YAML, and this just starts up an ephemeral Kafka cluster in a pod, and then also a Postgres database, also ephemeral, starting in a pod, so you can recreate this in your local environment. And then I also applied this configuration file, which I'll get to in just a second, to wire it all up. So let's deploy this real quick and see if it works. So I can do kubectl, which is the tool to interact with Kubernetes clusters, and then apply the target Kubernetes.yaml file. And that should apply that YAML that was created, or maybe not, if it says the validation is not right. The server has asked for the client to provide credentials. OK, so I need to log in. OK, so you can do this. So this is OpenShift. It's an implementation of Kubernetes. But you can, if you want to log into a cluster from the CLI, this is basically how you do it. It's a temporary token. And then just log in. And then now we should be able to apply this YAML. So let's see if that works. kubectl, apply, and then -f to point to a file. And then you can see here that it created, it's configured a service and created the deployment. So let's go look at it real quick. It's being deployed here. And we can see that it's running, or maybe not. It has an error, but we can go look at the logs and see the error is failure. It's not able to see a config map, it says. OK, well, that's fine. We can figure that out in just a second. So here we have config maps. And there's a config map properties, which I think was the one that we were pointing at. And this is the joy of working with Kubernetes, because you have all these different things that you need to connect to your application. Let's see what it says. Failure executing config maps properties is forbidden. OK, so I need to make sure that I can access the config map, which should be part of my Kubernetes YAML file. Actually, it's not. And that's gets us maybe to the second part of this talk. So I deployed this application to Kubernetes, but it's not ready for production, right? Because, well, first of all, it's failing. But there's several things that are kind of missing from my application yet. One thing is that when I start up my application, like I did now, it kind of starts up, but there's some time between, even if you've optimized it and it starts up in a few milliseconds, best case scenario. In most scenarios, it needs to connect to a database, and it takes some time to establish these connections. And in the meantime, when your application gets deployed, and it starts up, the container starts up, then Kubernetes thinks, OK, it's ready. We can send traffic to it. But instead, our application is actually not ready yet to receive that traffic, right? So especially if you have multiple instances that you're starting up, some of them are ready. Some of them may not be ready. You can actually tell Kubernetes which ones it should send the traffic to. And so that's what you can do by adding health endpoints to your application. This is very important in the Kubernetes world, so I highly recommend you add that to your application. So of course, that is maybe adding a little bit more YAML to your application, right? So you have three kinds of health probes in Kubernetes. You have readiness probes, you have liveness probes, and you have startup probes. So basically, to tell the application, or to tell Kubernetes, I've started up the application has started up. Readiness means it's ready, and that can also mean, maybe when it's running, it goes down, and then that readiness probe, which is what Kubernetes keeps calling, will not say that the application is ready, and Kubernetes will see, oh, I need to not send traffic to this particular pod because it's not ready. So you can add more YAMLs or YAML code to your YAML. So for example, here's a readiness probe, which listens to an endpoint on /health of your application. So you can add these health points yourself, or you can use something like MicroProfile, or Spring Cloud has this built in as well, to automatically add health points to your application. So that's something that, of course, I would like to do as well. And this is relatively easy to do. So if you're using Quarkus, what you can do is you can add the Quarkus small RAI health. So small RAI is an implementation of the microprofile specification. So in this case, let's say that I add this dependency to my application, and then because it's still running in this dev mode, you can see that it'll reload, and then I can see on my application on my local machine, running on localhost 8080, maybe if it wants to run. If not, we'll have to give it a little kick. I'm just going to start up the dev mode again. Usually you don't have to do that, but of course we're doing live demos, and then all sorts of fun things happen, of course. Okay, so just one more second. There we go. It's starting up the dev services for Kafka and the database, and then let's hit refresh, and then here we go. And so you can see here in the dev UI you have these health endpoints, so they're just listening on the /health or the /q health in this case. And you can see here that by default, by me just adding this extension to my application, it added these checks to make sure that my application is up and running. And because I also have dependency on Kafka and on the database, it adds the endpoint in that endpoint to the status of those connections as well. So that's a pretty handy way of creating health endpoints to make sure that traffic only gets sent if the application is ready. So definitely health endpoints, very important to add to your application. Another really important thing in your application from a Java developer is that you need to be aware of what kind of resource usage your application is using. This wasn't so important in the classic Java world, where we're just like, yeah, just use all the memory available on this machine, on this virtual machine. In the cloud native world, we need to be very aware of what memory usage is using, and then we need to communicate that to the Kubernetes cluster to say, hey, make sure there's a certain amount of memory available for my application, and perhaps you can also say this is the maximum amount of memory or CPU that your application is allowed to use. So those are two different things that you can configure in Kubernetes. So you can see here requests basically means I want at least this much this much resources available to my application. Otherwise, don't schedule it on this particular node. Schedule it somewhere else, which hopefully somewhere else has that kind of availability. So you can see here, I want at least 300 megs of memory available, and I want at least 250 millicores. And then in terms of limits, my application is allowed to only use maximum 400 megs and maximum 1 CPU. That's very aggressive. I wouldn't recommend this for every application. It's just an example, of course. But here's what can happen if you set those limits too low. The screenshot right there is what kind of can happen, right? It says out of memory. And this is exactly what Kubernetes will do with your application. If your application wants to use more memory than it's allowed to, it will kill your pod and restart it. So you'll see like OOM killed. So be aware of that. You can configure your JVM to take into consideration how much memory it has available, which is something that you should probably also do, and I'll show that in a second. So you want to state your intentions on Kubernetes even as a developer and be aware, right? So you can set a certain amount of limits. In terms of CPU, that could be a good idea. If you have a certain request, you will have that guaranteed. And if you have a higher limit, Kubernetes will give you more if it's available. If you go beyond that in terms of CPU usage, your application will start getting throttled. So it'll start getting slower, which is something that to keep in mind if you're like working in Kubernetes and you see your application is running slower, you might want to check your CPU because it could be that it's using more than it's allowed to, and it will not get killed. Whereas with memory, the application will get killed if it has too much memory. So those are the kind of two different resource considerations in Kubernetes. So our friends at Microsoft wrote a little article about, if you don't really know where to get started in terms of using resources, and they recommended, maybe give it your Java application 2 cores, 4 gigs of memory, heap size 75%. Don't set it to 100% because you will constantly get your application killed because there's a little bit of space in between, how much heap size you can use, and then there's memory use for other considerations in a pod, so don't set it too high. And then in terms of the garbage collector, since we're using multiple cores, you might as well use something like a parallel GC instead of serial because you have multiple CPUs available. So this is kind of a recommendation that they gave if you really don't know where to get started. But I do recommend being aware of the resource usage of your application and setting these values accordingly. So this is how you can set your application when you deploy it. You can set the environment variables, again, in your YAML. You can set the JDK Java options, and you can set, for example, I want to use parallel GC, and I want to use maximum RAM percentage 75% to make sure that we don't use too much RAM, because again, there's a little bit of overhead in your pod for other things, and that way the JVM will know I can only use 75% of the allocated memory for the application. Now we've looked at health endpoints. We looked at how to deploy our Kubernetes application. We looked at the resource usage. Another important concept in Kubernetes is secrets and config maps. So config maps are basically a way to externalize configuration values, right? So kind of like environment variables, you can store them in Kubernetes as a config map, and then they'll get passed into your pod. And then same with secrets. So they're not encrypted. They're just encoded values for maybe connection parameters or something. If you really want to have encrypted things passed to your applications, you want to use something like maybe HashiCorp Vault or something. Secrets are relatively okay for most things because they are encrypted at rest, ideally, if your system administrator does their etcd in Kubernetes, right? But that's kind of outside of our realm, I guess, as Java developers. But so to add secrets and config maps to your application, and this is what I was running into before when I deployed my application, is that you need to give your application the rights to access those particular values. So one thing that you can do is, if you're using Quarkus, to generate the YAML to be able to do that, is you can add the Quarkus Kubernetes config dependency. And so if we go back to our Kubernetes YAML, so it keeps regenerating the YAML based on these dependencies. And we're going to see that we're going to have some more things added to our YAML here to be able to access those different things. So let's see that happening. Yeah, so we now have a service account to basically tie the link between my deployment and what it's allowed to access via a service account. You can see there's a role binding, and then there's a role somewhere too. And those are basically what configures it to be able to talk to particular config maps and secrets in your application. And then in your application properties, you can define those here. So you can see here, I have a secret called Postgres and then a configuration map properties. And so by adding this to my application properties, the YAML in my Kubernetes will be updated to make those particular connections as well. So we'll see that in a second. In the meantime, I'm going to move a little bit faster because we're running out of time. Once we're on, let's say, our application is on production, we have, the health endpoints. We made sure that the resources are set correctly. We have access to config maps. We have access to secrets. We want to make sure that what's running on production, especially running, in different pods, maybe across different nodes and different servers, that we can pinpoint when there are issues, of course, right? So we want to make sure that we have observability of our application. So the projects that are, kind of the, let's say I don't want to say trending, but the most popular right now in the Kubernetes, in the Kube Native world is OpenTelemetry. And then in the Java world, Micrometer is a good project to make sure that you can export metrics and knowledge about the performance of your application in your application. So you can add that to your application in different ways. So since I'm using Quarkus, I'm just gonna keep using Quarkus. So in my case, I'm just going to add a couple more dependencies here to my application. So we got the OpenTelemetry and then a few different dependencies here. So I'm going to add those to my application. There we go. And then add those to the dependencies right there. I could have just uncommented that, but copy and paste. So you can see here, I added the Quarkus, the OpenTelemetry, and then the OpenTelemetry JDBC, and then Quarkus Micrometer Registry OTLP. So that's the OpenTelemetry format for the micrometer metrics. And so that will create traces of all my requests, so I can go and see, when was a request made, what are the logs that pertain to that request, which services were called. So I get a lot of information, and then you can tie that into a collector system that collects all that data, and you can go and consult that. So if you're going into cloud native world, that's something that I would highly recommend. Unfortunately, we're running out of time, so I just want to show the final demo real quick that has all these capabilities built in, and then you can race the car game real quick. So basically, to play this game that now we're fully on production, we have all these different capabilities. You can pick your own team to race, and let's go to version 2 directly, which is shaking your phone to make the cars go, which is pretty interesting. You can pick your team, so it should be either fondue or raclette. So choose wisely which team you want to be in. And then once everybody's ready, I'll go to the dashboard and we can see our little cars, and then we can race our final game of our, let's say, Kubernetes production grade Java application. So everybody ready with see a couple more people scanning the QR code. All right, 3, 2, 1. Okay, so let's see. I have the application here, and I need to go to the dashboard. Hopefully this will work today. Okay, I'll log into my dashboard. Okay. So we'll see if the players get loaded. Yes. And then, so once I hit the start button, you just need to shake your phone. So we're using the accelerometer of your phone. And then every time you shake, we send requests to our Kafka topic, and then I read all those requests here. So it looks like Fondue is more popular, 35, and then Raclette has 19 people. We take the average, so don't worry. That does mean if you scan the QR code and you're not shaking, then you're not very nice to the rest of your team because it's going to drag them down. Anyway, 3, 2, 1, go ahead and start shaking your phone. All right, so here comes the cars. I'm just going to take a quick picture. Whoa, we got definitely Team Raclette. Well done, Team Raclette. And who was the player with username Toast? Nice. You get a sticker. And everybody else, if you want a sticker, you can come too after the talk. All right. Just to wrap it up real quick, so if you want to look at the examples a little bit more, so the Quarkus Kubernetes Kafka DB is a repository that has the example of our MVP that has also the observability built in. So feel free to play around with it, and then let me know if anything doesn't make sense. I'm happy to help more. Quarkus observability goes a little bit more into that, and then the car racing game source code is there as well. You do need a OpenShift cluster for the Quarkus game, the way that we described the instructions at least. If you deploy it on a different Kubernetes, let me know. It'd be cool to see it there as well. And then, our developer advocacy program has a bunch of books that are available for you to download for free. So that's always something that we like to share as a freebie. And then finally, the slides are here. So if you want to, kind of review all the things that we went through, I know it was very quick. Apologies for that. But review it and let me know, and then feel free to connect on Blue Sky or LinkedIn. And then if we have any questions, I can take them on the side, because I know Brian's eagerly waiting for me to finish. All right, thank you.